Alrighty, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at probability tree diagrams. By the end of this lesson, you'll be able to construct probability tree diagrams and use them to solve problems. So what are they? Probability tree diagrams are diagrams where the weight or the probability of the outcomes at each stage is written on the edges or the branches of the tree. For example, a bag contains 3 black and 4 white discs. A disc is selected at random, its color is recorded, the disc is replaced, and then a second disc is selected at random. The probability tree diagram looks like this. So here we've got our start. I wouldn't even bother writing that word. And here we've got our first draw. We either get a black or a white disc. And in our second draw, if we got a black one, we could get another black one or a white one. Or if we drew a white one first, our second draw could be either black or white. Now, because this is with replacement, because here it says the disc is replaced after the first one is selected, the second draw will still be out of 7 because there are still 7 discs to choose from. Usually we would complete this by writing the outcome. So we could get a black and then a black and then a white and then black, and a white and then a white. We can also work out the probabilities. The probability of getting a B and then a B, a black and then black, is 3 out of 7 times 3 out of 7. We are always going to multiply the two probabilities. That will give us 9 out of 49. The probability of black and then white will be 3 out of 7 times 4 out of 7, which is 12 out of 49. The probability of white and then black is 4 out of 7 times 3 out of 7, which is 12 out of 49. And the probability of white and then white is 4 out of 7 times 4 out of 7, which is 16 out of 49. Now, if we were to add all of these together, we should get 1. So because they all have the same denominator, I'm just going to add the numerators. 9 plus 12 plus 12 plus 16 is 49. 49 out of 49 is 1. Okay, the probabilities should always add to 1. But what would this probability tree look like if there was no replacement? So we could get a black or a white disc. I'm just going to write first here. And then we could get black or white, black or white. And I'm going to label this second. I might just move this first up here. Now, there are 3 black and 4 white. So there's 7 discs altogether. 3 out of 7, 4 out of 7. But if we've taken a disc out and we don't replace it, now there's only 6 to choose from. So the first thing I would do is I'm going to make all of these fractions out of 6 because I know there's only 6 to choose from. Well, if we chose a black the first time, there's only 2 more blacks to choose from out of the 6. So I'm going to put a 2 over here. But if I chose a black the first time, there's still 4 white to choose from. And you'll notice that these 2 fractions will add to 1. If I chose white the first time, there's still 3 black to choose from. If I chose white the first time, now there's only 3 whites left. And we can see that these 2 will add to 1 as well. So, what are the outcomes? We can get black and black, black and white, white and black, and white and white. and the probability of these outcomes, we're just going to multiply the two fractions. 3 out of 7 times 2 out of 6. That's 6 out of 42, which is should be 1 out of 7. Probability of black and white, 3 out of 7 times 4 out of 6. Two out of 7. Probability of white and then black. 4 out of 7 times 3 out of 6, which will be, I think, 2 out of 7. And the probability of white and white is 4 out of 7 times 3 out of 6, which will be 4 out of 7 times 3 over 6, 2 over 7. And we can see here that when we add these all together, they all have the same denominator, so I can just add the numerators. 1, 2, 3, 4, 5, 6, 7 out of 7, which is 1. Alright, let's have a look at this example. One card is drawn from each of 2 packs. Use a probability tree diagram to find the probability that both cards are court cards, neither card is a court card, and one card is a court card and the other is not. How about I get you to pause the video and have a go with this one yourself. Okay. So because there are 2 packs that we are drawing from, it's not from one pack. From the first pack, there's going to be 52 cards to pick from. And it's either going to be a court card or not a court card. From the second pack, we're either going to get a court card or not a court card. And they are also going to be out of 52 because it's a different pack that we are choosing from. Okay. So how many court cards are there? Well, there's Jack, Queen, and King. 4 of each, that's 12. So there are 12 court cards, which means there must be 40 that aren't. And it's going to be the same thing for each of these ones. 12 or 40, 12 or 40. So the probability that both cards are court cards, so let's just write the outcome. Court, 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 not a court, not a court, court, and both of them are not courts. So the probability of court and court is 12 out of 52 times 12 out of 52. Which is 9 out of 169. And that's our answer for that one. Question B. Neither card is a court card. So that's this one here. So the probability that neither card is a court card is 40 out of 52 times 40 out of 52. Which is 100 over 169. And last question. One card is a court card, the other is not. Well, there's 2 of them. So this one, what we could just do, the probability that we've got court and not a court, or not a court and court, is we can just do 1 minus these 2 that we've already found, because we know that the probabilities will add to 1. So 1 minus 9 over 169 minus 100 over 169, which is 60 over 169. Question 2. A bag contains 6 white marbles and 4 blue marbles. 3 marbles are drawn in succession. At each draw, if the marble is white, it's replaced. If it's blue, it's not. Find the probability of drawing no blue marbles, 1 blue, 2 blue, or 3 blue marbles. I'll get you to pause the video, draw a probability tree diagram to help you out, and then you can continue playing the video to check your answers. Right, so we're going to either get a white or a blue. A white or a blue. And I might actually fill these probability edges out first as we're going through it. So we know that there are 6 out of 10 that are white and 4 out of 10 that are blue. You will notice that I didn't simplify these fractions, and I actually prefer it if you don't do that. It's a lot easier when we have without replacement, so we know how many are left. Okay, so if we've taken a white, we replace it, so there's still 6 to choose from, and there's still 4 blue. If we've taken a blue, we actually don't replace it, so now there's only 9 marbles to choose from. 6 of them are still white, but now there's only 3 blue. And for the third one, blue, white, blue, white, blue, white, and blue, white. So I'm just going to write here first, second, and third marble drawn. Okay, we need to do this because 3 marbles are drawn in succession. Okay. If we drew a white marble, it gets replaced, so there are still 10. I really should have, maybe I'll rewrite these ones. We'll have white at the top. Just keep it consistent. Okay, so that means there's still 6 white marbles, and now there's only 4 blue. In this branch here, we can see that we've picked a blue, so that means we need to not replace it. So now there's only 9 marbles to choose from. Now we've already chosen a white. Actually, no. That means there are 6 white marbles because we've replaced all white marbles, but there's only 3 blue. Okay, here we've chosen a white, so we needed to replace it, so there's still 9 marbles to choose from. 6 of them are white, 3 of them are blue. And down here, we selected a blue, so we don't replace it, so now there's only 8 marbles to choose from. 6 of them are white, 2 of them are blue. Okay, so in order for us to determine the probability of no blue marbles being selected, that means we got white, white, and white. So we're going to multiply these 3 fractions together. 6 over 10 times 6 over 10 times 6 over 10. Or 6 over 10 cubed, which is 27. So the probability of no blue, or maybe I'll just do it like this, of white, white, and white is 27 out of 125. The probability 1 blue, well, might help for us to actually write down all the possible outcomes, and then we can determine which ones only have one blue marble. So this one here is white, white, and blue. So yeah, we'll need to use that one. This one's white, blue, and white. So yeah, we'll need to use that. White, blue, and blue. Blue, white, and white. Yep, we'll need to use that. Blue, white, and blue. Blue, blue, white, and blue, blue, blue. So there's 3 that we need to work out. So if we were to scroll all over to the right, let's write down the probabilities. I'm only going to do it for these 3 because they're the ones I need. So we have 6 over 10 times 6 over 10 times 4 over 10. That's 18 over 125. What about the white, blue, white one? 6 out of 10 times 4 out of 10 times 6 out of 9. 4 out of 25. What about blue, white, white? We've got 4 out of 10 times 6 out of 9 times 6 out of 9. 8 out of 45. So now all I need to do is I just need to add those 3 together. 4 out of 25 and 18 out of 125, which is 542 out of 1125. Okay, question C, the probability of 2 blue. So that's this one here, and this one, and this one. So let's work out those probabilities. The first one, white, blue, blue. 6 out of 10 times 4 out of 10 times 3 out of 9. 2 out of 25. 4 out of 10 times 6 out of 9 times 3 out of 9. 4 out of 45. And blue, blue, W. We've got 4 out of 10 times 3 out of 9 times 6 out of 8. 1 out of 10. So now all I'm going to do is I'm going to add those 3 together. 4 out of 45 and 2 out of 25. Giving me 121 out of 450. Okay, last one. The probability of 3 blue. That's just this one here. 4 out of 10 times 3 out of 9 times 2 out of 8, which is 1 out of 30. Okay, so that's it for this video. I hope now you know how to actually construct and use probability tree diagrams. Thanks.